Hey everybody, it's Mr. Carr again. Today we're talking about 11.2, areas of regular polygons. So let's talk about what is a regular polygon to start. That is a polygon where all sides and angles are congruent. Okay, so it's all sides and angles that are congruent. You've done stuff like that. It's a square. Remember, it's got 4 congruent sides and 4 congruent angles. Okay, also an equilateral triangle. Okay, all 3 sides are the same, all 3 angles are the same. So that's what we're dealing with here is regular polygons, but we're going to go bigger than 4 sides. Okay, so some more vocab. Center of a polygon is the center point of a polygon. The other part that we like to say is that it's equidistant to all the corners and sides. Okay, so for example, all of these sides here, all these lengths to right there, those are all equidistant. Okay, same thing if I go to all these corner points. Those are all equidistant. So there and there. Okay, so that's what we have there. In this case, it is point J. The radius of a polygon, that is the distance from the center to any vertex of the polygon. So if I look at this diagram here, I can do that. There's a couple of them, but I like to just, I'll go with JE here. Okay, segment JE would be a radius because it's going from the center to a vertex. One of the new ones would be the apothem. The apothem of a polygon is the distance from the center to any side of the polygon. And in this case, that is going to be JK, center to the side. Now, one thing to mention is the apothem there is a perpendicular, it makes a perpendicular angle between the apothem and the side line. Central angle of a polygon, the central angle formed by 2 radii whose vertex is at the center. And I should have a different color there. So let's go with red. The vertex is at the center, formed by 2 radii. Okay, and it's very important that we understand that it's not just any 2 radii, they have to be next to each other. So for example, those 2 radii are next to each other, so that is HJ, so angle HJG would be a central angle there. Okay. Quick formula, sum of the interior angles of a polygon. This is a nice little one here for helping us figure out what is the sum of the angles all the way around a shape. So for example, if I want to add up all of these angles, so I have an octagon here. Okay, so I've got 8 angles. Those 8 angles are going to add up to a certain number that I plug in here. So if I want to find the sum of those angles for an octagon, I would do 180 times 8 minus 2, which is 180 times 6, which is going to give me 1080. Okay, so that 1080 degrees there, that is referring to 1, 2, 3, 4, 5, 6, 7, 8 angles added up. So a nice little feature of our central polygon is, what if I wanted, or sorry, no, I'll get to that in a little bit. All right, so if I want to find, let's say, these individual ones right here in a regular polygon, then I can actually take the 1080 divided by 8. That will give me each of these for a regular polygon. So if I do that, I got 1080 divided by 8, and then I get 135. That is the degree measure for each of these. It's 135 degrees. Okay, just something to be aware of for that part. I'm also going to focus more on the central angle idea. So in the diagram, this is a regular hexagon. Find each angle measure. So we're going to start with EGF. So I'll color code these. Start with green for EGF. Okay, that's the central angle. Okay, the central angle, if you notice, if I were to continue this on and draw in all my radii, look like this. I look at how many triangles do I create. So ignore GH for a second. I have 1, 2, 3, 4, 5, 6 triangles and 6 central angles. Well, these have to all be the same. So therefore, the measure of angle EGF is going to be 360, because that actually makes a complete circle like that. So I do 360 divided by my number, side 6, so I get 60 degrees. That's the measure of EGF there. And that's actually something to say on here. If I ever want to find the central angle of a regular polygon, I can actually just take 360 divided by the number of sides. So it doesn't matter if I'm dealing with a decagon, 360 divided by 10. Okay, I'm dealing with an octagon, 360 divided by 8. Those will tell me the central angles. Okay, that is different from this little formula here. That is the interior angles versus the central angles. Sounds similar, but these are my interior angles like that. Okay, these are my central angles that go around here. Well, now that I know that one, let's look at EGH. So EGH is right here. So EGH is the result of drawing in the apothem. So now that I know that that's 60 degrees from the first problem, we draw an apothem in, it actually is going to bisect that angle. It's going to turn those into two congruent angles there. So that means I could just take 60 divided by 2 and I get 30 degrees for EGH. Okay. And my last one is HEG. So that is HEG right there. Yeah, I didn't want that. HEG, like that. Well, based on the information I have, I kind of have this as a little reference triangle. I have a right triangle. I have this is 30 degrees, and this is the one I want to find. So I can just take 180 minus 90 minus 30 to get to that last angle. I do that, and I get 60 degrees again. Okay, so that's kind of just analyzing our angles that are formed inside of a regular polygon. Here's where it kind of gets into play. Let's find the area of a regular polygon. That has its own formula here. So the area of a regular polygon with side lengths, we'll call them S, is half the product of the apothem A and the perimeter P. Well, remember, perimeter is the distance all the way around a shape. So if I look at something like this, and I got side lengths here, these are all the same side lengths, right? Instead of me adding all those up, if they're all the same in a regular polygon, then I can find perimeter by just taking the number of sides times the side length. So this is a different way of doing that, okay? So what that means in terms of my formula, it is 1/2 the apothem times the perimeter. But again, because perimeter can actually be found by taking the number of sides times the side length, then I can do it this way as 1/2 the apothem times the number of sides times the side length. Either one of these works. It's 1/2 of ap or 1/2 of ans, like answer. All right, so let's apply that here. Find the area of a regular polygon. So a wooden coaster is a regular polygon with 3 centimeter. Well, that was spelled wrong. Jeez. Centimeter sides and radius of about 3.92 centimeters was the area of the coaster. So with these types of problems, I like to do this. I like to list out, do I have my apothem and do I have my perimeter? Okay, my apothem, I do not have. If I draw this in here, that's my apothem. I don't have that right now. My perimeter, I do have. It's 3, it's an octagon. So I can actually do 8 times 3 is 24. So I have my perimeter. I need to find the apothem. So here's the thing. Remember what I said before? I split that right there. I've created a right triangle when I draw that in. There's my apothem. My hypotenuse is 3.92. And the other thing that happens is I actually split that side up into 2 equal lengths as well. So what I have, I can use this as a reference triangle. Kind of blow it up a little bit. I have A, 3.92, and then 1.5. Okay, that's what I'm showing there. I could find apothem now using Pythagorean Theorem. Remember, this was a right triangle there. So that means A squared plus 1.5 squared is equal to 3.92 squared. So A squared plus 1.5 squared. It's going to give me 2.25. 3.92 squared is 15 point, I'm going to use all my decimals here, so 15.3664. So I can subtract this over. Okay, I'll rewrite over here. A squared is going to equal to 13.1164. And then I will square root this. Okay, square root that number there. And I get an apothem of 3.622. All right, so I've used Pythagorean theorem. So remember, a lot of those right triangle things are not going away We can get more challenging with that. We'll see if that pops up. But for now, just know that we can use our Pythagorean theorem to help us find our apothem. Now I have enough information to find my form or find my area. It is 1/2 the apothem, so 3.622 times the perimeter 24. So if I do that, I'm going to do times 0.5 times 24. And I get 43.460 square centimeters. All right, that is it. Go ahead and try out some of these. This one right here. It's kind of interesting idea that happens here. Oh, that's fine. Okay, here's our regular pentagon. Okay, squares are all, since they're regular polygons as well. Sometimes you can deal with that, like that's an apothem. I'm not finding area in this case, but find this one here. Remember with this one, you decide to try this out. When I draw in the apothem like this, that creates a right triangle and splits this side up into 4 and 4 like that. So that's my reference right there. So 6.8, 4, and A to help me find the apothem. All right, that's it for today. We'll go over some more of these problems in class, and then, well, that's it for all the different area formulas for areas. All right, so that's it for 11.2. Take care, everybody.